Hi, welcome back to the Nav Station. I'm Andy Howe. Here at the Nav Station, our goal is to get you confident enough to head out on the ocean, turn off your GPS, and get to where you're going using celestial navigation. We've gone through a whole pile of episodes, covered all of the celestial bodies, broken down sight reduction into many component parts, looked at plotting, and talked about all the tables that we need to use to do this. Now we're going to go back a little bit and examine plotting in a little more detail, as well as talk about what's involved in what I like to call a celestial day at sea. So the first thing we're going to do, though, is to go back and review the running fix. We've talked about this a little bit without a lot of detail, but it's integral to the day-to-day celestial navigation process, because this is what you use when you're taking your sun sights. Star sights, you get multiple bodies, you get a nice X's that mark where where you are. A sun sight, you just get one line of position. So you've got to have a way to utilize sun sights through the day as you compile all of your sites. So we'll start off just drawing an imaginary course line here. And let's say we have a DR here that we've put on this course line based on information previous that's off our piece of paper. And let's say it's in the morning, so the sun is more or less ahead of us off to the east, which means that a line of position is going to be something like this. A little bit of an exaggeration all the way around, but the general layout will be the same. We're going to call this LOP1, and we're going to call this DR1. Doesn't matter what the time is or the intervals that we'll be describing here. It's just a way to differentiate them. Now, as we described in the plotting episode, this line of position represents this big circle of equal altitude with the sun somewhere down here, the sun's geographic position somewhere down there. We know that we're somewhere on that line of position because by definition, every point on this line, if we took a sight at the same time, would have the exact same altitude recorded on its sextant. And the way we pick a position is to pick the position that's closest to our DR. So we go perpendicular to the line of position that crosses our DR, and that position there is called our estimated position. Again, estimated position number 1. That's taking one sun line and incorporating the dead reckoning position onto that sun line to give us an estimated position. Now, based on our course and speed, we'll draw our track out this way, and this would be erased because we're no longer putting a DR plot on this track. We're going to use this track, and we would go forward, let's say 3 hours, and we'll put DR number 2 based on our course and speed, which we're not going to label here or anything, but it would typically be labeled just to keep yourself honest with what information you have. Now, later through the day, let's say 3 hours later, the sun's bearing, instead of being here, remember perpendicular to this, that big circle, the sun has moved down to the south. So a line of position is going to be more like this. The sun's bearing is down here. Again, this is part of that great circle of equal altitude that represents our line of position number 2. Now, we could just take the DR and find the closest point in the line of position 2 to DR2 and make that an estimated position. But since we took the DR and we've assumed that this is our estimated position, and we've taken that estimated position and we've used it to advance that one spot to here, to this DR based on course and speed, we're going to take every position on this line and we're going to advance every position on every part of this line, the entire line, up to this DR. And this becomes line of position 1, 2. We've run this forward, advanced it based on our course and speed up to our DR. Using our plotting tool, all we have to do is move it until it intersects the DR and scribe it in, and we have the makings of a running fix where these two positions cross. These two lines of position cross. So instead of just taking one position and when we get to here and then getting an estimated position, we take every position on this line of position, we move it forward, and where it crosses the new line of position, that's our running fix. So another segment of time, the sun is down here now. Let's say we're going to noon, and the noon site, the sun is, we'll just say it's due south. First of all, we're going to take our track and we're going to advance from here now, and we're going to go out this period of time. This becomes DR3, and the sun is now due south. So let's say that the line of position is right in here. That's our local apparent noon site. And again, we take the most recent one of our lines of positions and we advance that to the DR and we draw it in, and this becomes line of position 2 to 3. And again, this now down here becomes our fix 3, associated with the sun's noon latitude at noon and this advanced line of position. And we would then take our DR plot from this point forward and advance that, plot DR, and do the whole thing over again. And that's how we go through the day. Now, there might be a time in here where one of these doesn't make sense. It's entirely possible. And then you have to go back and look at the dead reckoning information you've got. Is the course and speed in the logbook accurate? Did you get a good sight at time 2 or time 1? Is something off? Or is there some other thing that's influencing your passage through the water? Are you anticipating a current that's going to be headed in this direction? If you're crossing the Gulf Stream on your way back and forth to Bermuda or Europe, you're going to encounter currents. Other parts of the world, you're going to encounter currents as well. And you can pick that up by just seeing what happens with your fix information as you go through the day. It's pretty accurate. But you have to remember that a running fix is not as precise as, say, a star fix where you have multiple bodies with multiple lines of position all crossing essentially in one spot. This is a refinement on the estimated position, which is a refinement on the DR. Remember the hierarchy of positions we described earlier? And the next step would be a multiple body site, whether it's a star site or maybe we get a local apparent noon and a moon site at the same time. You would put those in there. You can still advance your earlier line of position for the sun. That just makes it that much better. So the more information you have, the better you are in terms of the hierarchy of your positions, as we've described. So that's the mechanics of running fix. We'll illustrate it more precisely on a plotting sheet after we finish some more descriptions. But it's what you do through the day with your sun site navigation. All right, so what's involved in a day at sea? Okay, well, the first thing to think about is how can you plan for it? And we've described all that in previous episodes. You need to find out your twilight times. So first is to figure out the time of morning twilight, and then pre-calculate your stars and any planets and the moon that might be visible. Next is to check to see if planets are up during the twilight hours. That can all be done at the same time. Same thing with the moon. Is the moon up during the day or at twilight so that you can utilize it for your celestial navigation? Obviously, the moon's advantages is very identifiable, so if it's there, you always want to take sights of it. Now, the other planning part is the noon sight. What time is noon sight going to be approximately? You can plan ahead for that. Fifth would be planning for your twilight in the evening. And again, are the planets visible? Is the moon visible at this twilight time? In between these two periods, twilights in the morning and twilights in the evening, is when you're going to be taking all of your sun sights. And I'm of the school that the more information is the better. You don't have to go crazy. You don't have to be taking sun sights every half hour, every hour. Every couple, 3 hours, I like, depending on what's going on, it's good to get out and get a series of sun sights. I've also talked about how at one setting, get multiple. I like to take 3. Doesn't take that long, and doesn't take that long to reduce them since a lot of the information is the same as you go through the reduction process. That way you can see that one of these wasn't so good, so we're going to cross that out and just pick one of these or pick a point between them as the actual line of position. This is very important to do, I think. You can't do it with stars generally. You could do it with the moon. It's tough to do with planets. You can do it with a very bright star. You can take a bright star sight at the beginning of twilight, and if it's really bright, you can take it again at the end and see how they compare. But very important for the sun sights to take multiple sights at each sitting so that you can eliminate any potential errors, of which there are many. Whether you make the error in the sight reduction process, you take a bad sight, you misread your sextant or your watch, there's opportunities everywhere for things to go bad. Usually it's just human error, which is why I recommend doing multiple sights of the sun at every sitting, or standing, or every sight process. So pre-calculating all of this information is key. And this doesn't have to be done on the boat. You can do this before you depart because you can roughly guess what time twilight is going to be for your entire trip. It's not going to change a whole lot. If it's a long trip and you're covering a lot of ground, yeah, you might have to redo it every 2 or 3 days. But generally for a week or 2 passage, it's pretty much the same. Or close enough so you can get used to it. So you can pre-calculate your initial twilight times, you can pre-calculate planets that'll be visible, you can pre-calculate whether the moon is up or not, and you can get a rough idea of the noon sight, although that's pretty quick to calculate, so you don't have to do too much of that ahead of time. The thing is, if you're on a trip of a week or 2, the stars that are going to be in the sky at morning twilight and evening twilight are really not going to change very much. They're going to move in the heavens, they're going to shift their positions a little bit in terms of their altitude, slight change in their bearings, but the ones you see at the beginning in the morning are going to be the ones you see pretty much a week later at the end of your trip. So it's not something you have to agonize over every single day. You can get your list of all your possible targets for shooting stars and then refine them to the ones that work best, are easiest to find, and are consistently available in terms of the position of the boat and are easy to shoot. So that's planning. As I say, you can do that ashore or at the nav station before you leave. but you don't have to do it every single day fresh because it's going to be pretty similar all the way through. Now, when we're doing our plotting, whether it's running fixes or star fixes or whatever it is, we're relying very heavily on the dead reckoning information, which comes out of the logbook that's kept by the watch. And it's up to you as navigator to impress on the watch that it's very important for the accuracy of your work that what they record in the logbook for course and speed is very important. And I like to have, particularly on a race where it's important to be ahead of the game in terms of where you're headed, I like to have logbook information recorded every hour. If you're on a longer passage, casual passage, you probably don't need to do that, every couple of hours. But it's good discipline for all of us to look around, remember what you steered for that hour and what the speed was generally, put it in the logbook, and then it's up to you as the navigator to take that information, work with it, and uncover any potential mistakes in your work or in the logbook information. So just figure out what's going to work best for you and just make sure your shipmates cooperate and give you the information you need. Okay, that is the basics of the running fix and setting up for a day at sea. One other thing before we go look at some exercises on a plotting sheet. When you have, whatever your course is, let's say we're still using this course. We'll go with a different color now. We'll use green. So this is our course. Anytime the sun, we'll talk this because this is most commonly done with the sun because we get the chance for many times during the day to take sun sights. Anytime the sun is approximately dead ahead or dead astern, more or less, you have the opportunity to get a line of position that is more or less perpendicular to your track line. And that's very helpful in determining progress down your course, progress towards your destination. So look for those opportunities where the sun bears either directly ahead or directly behind, close, doesn't have to be exact, so that you can get this information to refine your DR and your running fixes. Similarly, look for the opportunities when the body, the sun, is nearly parallel to, the LOP would be nearly parallel to your course line. That will give you the opportunity to get cross-track information from your plotted dead reckoning course and confirm or deny or show you the effect of something you knew about or didn't know about, i.e. a current. If you're anticipating a current that's going to be working this way, you want to try to get sun lines that parallel the course so you can see if you're being set in this direction, as we seem to be on this particular exercise here. So very helpful to plan your sight taking so that you get both cross-track information, how are we making progress towards our destination, and track information and cross-track information, are we getting set one way or the other from our course line. And you'll get used to what times a day that occurs. A noon sight, for example, on this particular course is going to be pretty good at giving us cross-track information, whereas an early morning or late afternoon sight is going to be good for giving us our progress information on our track. So that's just one of the things you can look out for and utilize to your benefit. And if you do the more and more of this you do, the more you get used to it, and the interpretation you can bring to the chart is what's really going to help you get more accurate and provide good information for your future planning and for what the boat's going to have to do going forward as you move through your passage. Okay, well that's the basics here. We're going to shut this down and come back set up to look at a plotting sheet. Just do some more like this. just to show you what it looks like with the entire day laid out on a plotting sheet. All right, so here we have a made-up day at sea on the plotting sheet. What I've assumed is a course of 130 true and a speed of 7 knots, which is taking us roughly this way, imagining a trip from the East Coast over to Bermuda, roughly. And I plugged in what I would normally do on a plotting sheet for passage if it applies, in this case, the Gulf Stream current, the axis of the Gulf Stream with an estimate of 3 knots of current. And then here's where I projected a imaginary meander starting for the Gulf Stream. So I've got some elements to play with here. And we'll just walk through these made-up lines of position to see how they come together to give you a full day of navigation. We start off with a star fix at 4:30 in the morning, and then from there we project a dead reckoning position down to 0830, 4 hours later, on this course and speed as indicated here. Once we take a sun line at 8:30, we plot that and we calculate an estimated position based on the DR and the closest point on the line of position to the DR. Now, we could have run forward one of these LOPs from a star site, but 4 hours is a long way to do a running fix for, I think, so I'm not usually doing that with star fixes from either the evening into the morning or from a morning star fix into the morning set of sun lines. So we've got an estimated position here, and then we continue our track of 130 at 7 knots down here 2 more hours till 10:30 for a DR, and then we plot another line of position for the sun at 10:30 and advance the line of position from 8:30 in the morning. Just advance that down parallel to itself down till it goes through the DR and draw that in, and then write in the times for that advanced line of position, in this case 0830 to 1030. And where that advanced line crosses our new line of position, that becomes our 1030 running fix. And you can see, as I've indicated here, we've kind of gathered that there's a current in effect here. In this case, I calculated it to be about 3 knots based on the distance from the DR and in a roughly northeasterly direction. So that would indicate to me that perhaps this meander is starting a little earlier, or there's some other dip in here, or maybe the projection I had for the current is a little off and maybe it's more in this direction. Any one of those things might be applicable, and you just have to go back and take a careful look at what you plotted on your general sailing chart for current, in this case, and see what applies or what makes the most sense. Of course, if we had doubts about either of these sun lines, we might not create this running fix. We might go with, again, the point closest on the LOP to the DR if we didn't want to advance the line of position for some reason. But in this case, we'll make the assumption that everything was good, and we'll move forward from this running fix to plot a DR for our latitude at noon, our time of meridian passage. And then when we plot that in as a line of position at local noon, which is 12:45, again, we take the 10:30 line of position and we advance it parallel to itself until it crosses through the DR down here, and where that intersects the line of position for the noon sight or the latitude line, that becomes the running fix at 12:45. And again, that seems to indicate a current pushing us to the east and perhaps a little bit to the north, which corresponds with our projection for a current in this part of the ocean. So again, we're able to take a look at what we guess to be a current and then confirm it. Maybe not exactly, but confirm it to the best degree possible. In this case, 2 or 3 knots, roughly east-northeast. And also note that as we move down this track line, this line of position and this line of position are roughly perpendicular. So that's giving us a good indication of our progress down the track line. In this case, the 8:30 line of position pushed us ahead a little bit of our DR. So we'd say something's going on there. And then this line of position at 10:30 just by itself seemed to retard our DR a little bit. So again, maybe our estimate of current is a little off, or it's getting closer to a more northerly set than we had back here earlier in the morning. All these things go into your analysis of your plot once you get things onto the paper. Then from 12:45 local noon, we advance our dead reckoning position down here till 1600. Let's say there's an afternoon of clouds and we can't get a good sunline. Perfectly common occurrence. So we take a line of position at 1600. Again, remember the sun is on its move from here, pointing towards the geographic position, to here. This is the line of position pointing the geographic position, to latitude at noon, pointing the geographic position down to our south, and then over here pointing to the west for the geographic position of the body, and this being that big line of position, circle of equal altitude that we've been talking about. So we have a 1600 line of position, and we advance the latitude line down to the DR, and we come up with another running fix at 1600, which seems to have made the current appear to be pretty much dead easterly, which might indicate that we're getting closer to the round point, the hump of this meander. Then from 1600, we plot a DR out to 1800, another 2 hours, and take another sun line in here, which is labeled 1800, and again advanced 1600 parallel to itself over to the DR, and we come up with an 1800 running fix. Again, seeming to indicate the current has maybe now turned more to the south, which is what we would have drawn on the chart based on our Gulf Stream forecasting that we pulled before we left on the trip. Or if you've got the electronics to do so, maybe you're getting active updates on your currents as they're projected in the weather apps. Then 1800 running fix, again, we're still in the same course. Of course, if the course changes anywhere in here, you would update your course line appropriately and accommodate that change into your dead reckoning plot so that you're always reflecting the current course and speed, or the most up-to-date course and speed, as you go through the day based on the information in the logbook from each watch. So the 2030 dead reckoning position, we had the moon pop out just at twilight, and we've got a moon sight in here, moon line of position in here, and then we advance the 1800 line of position, and where those two cross, we now have a 2030 running fix. And if the stars don't come out or don't appear, or the horizon is hazy or obscured or unusable for some reason, you at least have a running fix just at twilight that you can use, from which you can calculate your DR position through the night and then be ready to take star sights again in the morning. So all of these things come into play during the day. And I think at a minimum you want to take 2 sun lines of position, 2 sun sights during the morning after your star sights, assuming you get some good star sights, and then take your latitude at noon, your noon sight for latitude, and then 2 more in the afternoon for sun lines before you get into any kinds of twilight and star sights that you might be able to get in the evening. If the moon comes up during the day, which it does periodically, you just put one of those in there with a sun sight, and you get 2 lines, which is a pretty good deal to have during the day. It doesn't happen every day, but if you combine that with a running fix of the sun line earlier, then you've got 3 lines of position that you could put onto the chart, interpret how they fit with your DR and any currents, and you have a pretty good fix to work from in the middle of the day. So notice that on this made-up example, of course, we don't have any assumed positions, we don't have any ZN lines, and typically you would only use a very faint pencil mark for an assumed position, and in terms of constructing the ZN line to get your LOPs drawn in, just use a dotted line for the ZN lines, or a line that's light enough that you can erase. You can end up with a ton of lines on a chart in the course of a day, as you can see here, covering almost 12 hours or more. But if you can get rid of the ZN lines and the assumed positions, then you don't get too confused. It's also very important, to the best of your ability, to label everything as clearly as possible. You may have a different way you like to label things. This is the way I've developed over the years. It's clean for me. It works. You just have to make sure you put things out of the way, and if it means drawing a line of position extra long so you can label it out of the way of your day-to-day work, that's fine. Whatever seems to make the most sense for you and how you like to use your chart. One thing I'll point out about these plotting sheets, which we sort of touched on but didn't really develop, is you can blow the scale up here, since you're going to be consistent. You could say that each of these spaces between your what's now a degree of latitude is a half a degree of latitude. And then each of the spaces between what's now a degree of longitude would then become a half a degree of longitude. So you can get a larger scale out of this by just relabeling things and making it fit whatever you want. Sometimes that's helpful if you've got a lot going on. I never tend to have to do it that often, but you can see here that we can easily fit a full day and then some onto one plotting sheet. And as you move down the plotting sheet, you just lay the next one on, overlap the grid a little bit, and draw in, trace it in, or you can plot it again at the next corner that you're going to be attacking on your next sheet, and just move on from there. And I like to label my plotting sheets, so this might be number 2, and then the next one heading off in this direction would be number 3. That way I can go back and recreate them if I need to in the proper order, and put the right information onto a general sailing chart. I always like to have a general sailing chart that gets marked up 2 or 3 times a day with just a position and an indication of what it is. So you don't need to put all this detail on the general sailing chart, but you might want to put in the star fix, maybe a mid-morning fix, the latitude, and so forth through the day. So you have enough information on there so you can see how your voyage is going and see it in the context of the entire passage from start to finish. All right, we're going to close out this episode on a day at sea and planning. with a look at one creative solution that a friend of mine developed a number of years ago to help celestial navigators manage the plotting and navigation for the Marion to Bermuda race, which still maintains a celestial navigation class. The Marion to Bermuda race is held every other year on odd-numbered years, whereas the Newport Bermuda race, which is held every other year on even-numbered years. I've used this system for a lot of years. As I said earlier, I've done maybe 8 or 10 Marion to Bermuda races, all celestial, and all using this particular system. What this person did was take International Chart 403 or the NOAA Chart 108 and reproduce it in acetate, and only reproduce the portion of the chart that's relevant to the race, i.e. from the latitude of Bermuda approximately up to the northeast. And I used this overview chart to plan the race. I've got the rhumb line on here. I've been using plotting 2 or 3 positions a day just to mark our progress down the track line. I've incorporated some information in here about the Gulf Stream. This was for the 2019 race, the last time we held the race. And all that information can be updated as you go through the race. If you have new information on the position of the north wall of the Gulf Stream or any eddies, for example, you can erase and reposition them. The advantage of this is that once you're done with the race, you've got a permanent record. You can take a picture of it, file it, and erase all the information for that particular race and use it again the next time. The chart is scribed off into 3 boxes, and each of those represents a plotting sheet. So there are 3 plotting sheets that come in this same acetate to cover the entire rhumb line from the east coast of Massachusetts to Bermuda. And so while you do your planning on this sheet, your day-to-day navigation is done using one of these sheets. And this covers from the corner of Buzzards Bay down to this corner. And I've got the rhumb line drawn on there. I've got the north wall of the Gulf Stream as we recorded previous to starting the race, and the beginning of a little meander dip there, and plotted some positions in the first 2 or 3 days of the race as we move down towards the Gulf Stream. Once you get down near the edge here, you pull out chart number B, and that takes you on the next phase. And again, the rhumb lines continues on here. Here's that meander, and here's an eddy that's sketched in, and the positions for our navigation as we've gone through those 2 days. And when you get to the bottom, you switch over to chart number 3, which takes you from, again, here's this eddy, and takes us down, again, the rhumb line in there, down towards Bermuda. And on here, I've drawn in the 50-mile radius from North Rocks beacon that we are allowed to turn on our GPS. And then from here, typically get onto a Bermuda sailing chart and navigate our way in to the finish line. But the beauty of this system is, of course, that you can do a lot of pre-planning on the sailing chart ahead of time, and you can update it as you go through the race, whether it's with the current Gulf Stream information, weather information, or whatever you want it to do. And then when you're done, you've got a complete record of your passage, your race, and again, you can save that digitally with a photograph, and then you can use these sheets multiple times. It's proven to be a big help in celestial navigation because, unlike on a plotting sheet, this is simply 3 sheets, and they tend to fit together so that you can put them in context and see how you're doing as you go through the 4 or 5 days it takes to get to Bermuda on a cruising sailboat, for example. And if you're interested in finding out more about where these come from and how to get them, they run, I think, about $120 to $150. I may be out of date on that number. And I can provide information on the address of where to write to the creator. So that's it for this episode on planning and a day at sea. One thing that's come up from time to time is how to record all this information, and it really is a matter of personal preference. There's no right or wrong. You just want to make sure that you have a system that you adhere to both for your own site reduction work, your own site taking, and then the dead reckoning information, the course and speed, and other general information that needs to be recorded in the logbook from watch to watch so that you're able to reconstruct the day in the night and use that information to refine your position as you move along on your passage. And that's it. So thanks for stopping by the nav station. Look forward to seeing you back here next episode. We've got a couple more to do to cover some miscellaneous topics, and we'll get to those shortly. In the meantime, practice your site reduction and get out there and do some navigating. Thanks for stopping by.